All right, let's jump right in. We're about to take a journey deep into the future, a billion years from now to be exact, to see how the final chapter for planet Earth really plays out. And just so you know, this isn't a story about anything we did. This is about cosmic forces, things so big they make us look tiny.
You know, when we think about mass extinctions, our minds usually go to the asteroid that took out the dinosaurs, right? Or maybe the Great Dying, which wiped out something like 96% of all marine life. But believe it or not, there's an event coming that will make those look like a walk in the park. An extinction so total, it will literally sterilize the entire planet. So what on Earth could do that?
Well, here's the twist. The culprit is the one thing we absolutely cannot live without. The very star that made life on Earth possible is, over the next billion years, going to become its executioner. That delicate balance that has kept our world humming along for so long, it's about to be completely shattered.
Now, before we explore this distant, deadly future, we've got to set one ground rule. For this thought experiment, we're taking humanity completely out of the picture. This is the story of our planet's natural life cycle, a story written only by the laws of geology and astrophysics.
So here's a quick roadmap of where we're going. First, the continents are going to do a total reshuffle. Then, we'll see the plants die off, the oceans literally boil away, and in the grand finale, the Earth itself gets, well, eaten. Let's start with the ground right under our feet.
So the first act in this whole planetary drama starts deep inside the Earth. Those tectonic plates, the foundations of our continents, are in this constant, super slow-motion ballet, and they are not stopping anytime soon. Over the next 100 million years or so, this dance is going to completely redraw the world map as we know it.
If we peek just 100 million years into the future, things get pretty wild. Based on how things are moving now, Africa is on a collision course with Europe. That's going to close up the Mediterranean and create a mountain range that could be even taller than the Himalayas. Meanwhile, Australia will have cozied up with Southeast Asia, and get this, parts of California will have slid all the way up the coast to become neighbors with Alaska. Okay, now let's fast forward to 250 million years from now. All of these separate land masses, they all come together. They converge to form a brand new supercontinent called Pangea Proxima. The Atlantic and Indian Oceans? Gone. They close up, squishing the Americas, Africa, and Eurasia into one single colossal piece of land.
And having a supercontinent like this has some absolutely devastating consequences. When you have one giant landmass, you completely mess up the ocean currents, which turns the deep oceans into these massive anoxic dead zones. The inside of the continent becomes a scorching hot desert, leaving any land mammals that are still around huddled at the cooler polar regions. But honestly, as dramatic as all this is, it's really just the opening act for what's coming from above.
So let's talk about the main event, the real driver of Earth's ultimate fate. See, our planet has this amazing natural thermostat, a feedback loop that's kept our climate in check for ages. But our sun is getting older, and it's about to hijack the whole system. And this is it, Earth's planetary thermostat. It's called the carbonate-silicate cycle. It all starts when volcanoes pump out CO2. That CO2 then dissolves in rainwater, which makes the rain slightly acidic. As this acid rain hits the ground, it weathers rocks, washing minerals down into the oceans. Tiny marine life uses those minerals to build their shells, locking the carbon away on the seafloor. Eventually, tectonic plates drag that seafloor back down into the mantle, and the whole cycle starts over. It's this beautiful, self-regulating system that's kept our climate pretty stable for a very, very long time.
But here's the catch. Our sun is aging. As it burns through its hydrogen fuel, turning it into helium, its core gets denser and hotter. This just speeds up the fusion reaction, which means the sun's total energy output, its brightness, is slowly but surely cranking up. And that extra energy from the sun completely breaks our planetary thermostat. The increasing heat supercharges the weathering of rocks. It basically puts that part of the cycle into overdrive. So now, CO2 is being pulled out of the atmosphere way faster than volcanoes can put it back in. And the result? Atmospheric carbon dioxide levels just start to plummet.
This is what kicks off what you could call the plant-pocalypse. Most of the plants we know, like trees and wheat, they're called C3 plants. They need a good amount of CO2 to live. So in about 500 million years, when CO2 levels drop below 150 parts per million, they'll start to die off on a massive scale. The more efficient C4 plants, like corn, they'll hang on for a few hundred million years longer, but their time is running out too.
So at the very base of the food chain just crumbling and the sun getting brighter and brighter, the entire planetary system just starts to completely unravel. Earth begins its slow, painful transformation into a truly alien world.
Okay, jump forward 1 billion years from today, and the picture is just grim. The sun is now 10% brighter, which pushes the average global temperature past a blistering 50 degrees Celsius. With no plants to produce it, oxygen levels in the air have crashed to about 1%, making it unbreathable. And this is wild. Over a quarter of our ocean water has literally been absorbed down into the Earth's mantle by geologic processes. As the oceans that are left get hotter and hotter, they start to evaporate, dumping massive amounts of water vapor into the atmosphere. And since water vapor is a super powerful greenhouse gas, it acts like a thick blanket, trapping more and more heat. This kicks off a runaway feedback loop that there's just no stopping. At this point, Earth is on a one-way trip to becoming the next Venus. The surface is just a barren wasteland, covered in huge dune fields and vast salt flats where the oceans used to be. And without water to act as a lubricant, the tectonic plates grind to a halt, freezing the continents in their final positions. By 2.8 billion years from now, the average surface temperature hits a staggering 190 degrees Celsius. This is it. This is the point of no return. It's a temperature so high that it will kill even the toughest microbes hiding deep underground. All life on Earth is officially gone.
But the story doesn't quite end there. The planet might be dead, but the sun still has one last, incredibly dramatic act to play, and it's going to serve as Earth's funeral pyre.
So in about 6 billion years, the sun finally runs out of hydrogen fuel in its core. Gravity takes over, the core collapses, and that ignites a shell of hydrogen burning around it. This unleashes a furious surge of energy, causing the sun's outer layers to swell up to a monstrous size. And just look at the terrifying scale of this. The sun is going to swell to 256 times its current size. Now you might be thinking, well, won't Earth's orbit also get wider and move it out of the way? And yeah, it will, but not by nearly enough. The sun's new edge will reach 256 units out, while Earth's new, farther orbit will only be at 225 units. There is simply no escape. And this isn't just a theory. Recent research pretty much confirms this grim fate. Scientists looking at other star systems found a suspicious lack of planets orbiting red giants, which strongly implies they'd already been swallowed. As the study's lead author, Dr. Edward Bryant, put it, these stars are brutally efficient at consuming their inner worlds.
After it vaporizes Mercury, Venus, and our own planet, the sun will shed its bloated outer layers into space. And all that's going to be left is its hot, dense core, a white dwarf, that will just slowly cool and fade over trillions of years. A stellar tombstone in a dead solar system.
So this fate seems to be written in the stars for our planet. But does it have to be the end of our story? I mean, we're a species that's pretty good at rewriting the rules. If we can survive long enough, a few million years is an eternity for technology to evolve. Maybe our future isn't tied to this one rock after all, but to the stars.